Solve the system of equation x minus y equals 3, x cubed minus y cubed equals 387. Observe that we won't be able to multiply x squared or y squared because x and y are not constant. So we can't multiply a variable to an equation to use elimination. But with x cubed minus y cubed, this is the binomial. We can factor it. This is x minus y times x squared plus xy plus y squared. How do we know that this is the correct factor? We can multiply this out and check that it is indeed x cubed minus y cubed. And so this system of equation can be rewritten as x minus y equals 3. X minus y times x squared plus xy plus y squared equals 387. But if we were to view x minus y as a whole block, then we can substitute x minus y in the second equation with 3. We still have x squared plus xy plus y squared as one of the factors. This equal to 387. But if x minus y equals 3, then it must be the case that x equals 3 plus y, or y equals x minus 3. It doesn't matter which one we use for the substitution. From this equation at the bottom, we divide it by 3 to get x squared plus xy plus y squared. 387 divided by 3 is 1. 8 divided by 3 is 2. 2 left. 27 divided by 3 is 9. 129. We then substitute 3 plus y into where x is. And so instead of x squared, we have 3 plus y, the quantity squared, plus, again, instead of x, we now have 3 plus y times y, plus y squared equals 129. And so this equation now only has one variable. We then simplify this. This is 9 plus 6y plus y squared plus 3y plus y squared plus y squared equals 129. Combine like terms, we have 9 plus 9y plus 3y squared equals 129. This is a quadratic, so we will zero this out. 3y squared plus 9y plus 9 minus 129 equals 0. So we have 3y squared plus 9y minus 120 equals 0. To solve for y, we first divide by 3 to simplify this equation. If we divide by 3 from both sides of the equation, we have y squared plus 3y minus 40 equals 0. And we can factor this. This can be factored at y minus 8 times y minus 5. But minus 8 times minus 5 is positive 40, and we would need the two numbers to add up equal to positive 3, and so the larger number has to be positive. Y plus 8 times y minus 5 would work in this case. This is the zero product, so we see that y plus 8 equals 0, or y equals negative 8, or y minus 5 equals 0, or y equals 5. With each of these y, we have a corresponding x. Remember that x equals 3 plus y. So if y equals negative 8, then x equals 3 plus negative 8, which is negative 5. If y equals 5, then x equals 3 plus 5 or 8. So we have two solutions. The first solution is x equals 8, y equals 5, an ordered pair. The second solution is x equals -5, y equals -8. And we should check this. If we take x equals 8 and y equals 5 and plug it into the first equation, we will have 8 minus 5, which is 3. That checks out. If x equals 8, 8 cubed minus 5 cubed, and this will give us 387, so this checks out as well. For the second equation, if we take x equals -5 minus y equals -8, then this is -5 plus 8, which is 3. It checks out. And the second equation, x cubed is now -5 cubed minus -8 cubed. But this is the same thing as positive 8 cubed minus 5 cubed. So this is 387 also. So we have two solutions to the system of equations.